Hello, let's look at four examples of finding the limit at infinity. So when we look at limits as x approaches infinity, we can think of it as a tug of war between the top and the bottom. And we are looking for which one is going to win. Is it the top or the bottom, or are they equally matched? And these are the three possibilities. So here the top exponent is bigger than the bottom, and then the answer will be infinity because the top piece grows faster than the bottom. And so if we picture ourselves looking at a fraction where we have the top and we have the bottom, and we're looking at the top exponent and the bottom exponent, so we're looking for the highest power on the top and the highest power on the bottom. So in our first example, the highest power on the top is 2. The highest power on the bottom is 1 because there is no power. So the top is bigger than the bottom. And that means the top is going to win, and so it will grow faster than the bottom. And if the top number gets bigger than the bottom number, then the entire ratio gets bigger and bigger and bigger. And so the grand result is that that limit is going to go to infinity. And so our answer to the first question is exactly infinity. Now, if the powers are matched, that means that both grow at the same speed, and so nobody is winning. What happens is then the limit becomes the ratio or the division, the fraction of the leading coefficients. And we'll look at that example in a minute. And then finally, the top can have smaller power than the bottom, which means the bottom is going to grow faster than the top. And if the bottom grows faster than the top, then the entire ratio gets smaller and smaller and smaller, and eventually will go to 0. So these are the three possibilities, and we've already answered the first example. Let's look at the other three. So here is the next example. It's the same exact setup as what we've seen in the first example. The only difference is x is going to negative infinity as opposed to plus infinity. So what will happen this time? The top keeps going to infinity. It gets larger and larger. The bottom also grows to infinity because 4 times infinity is infinity. Even if you subtract 1 from infinity, you still get infinity. So which one is bigger? Which one is growing faster? The top is growing as something squared. The bottom is growing as something 1 to the first power. Which means if we plug in some x number, let's say x is negative 10. Well, negative 10 squared is 100, but negative 10 times 4 is negative 40. If we go more, let's say instead of negative 10, we go to negative 100. Negative 100 squared is positive 10,000, but the bottom is just negative 400. So the top grows much faster than the bottom, which means the answer is still going to be infinity, but this time the bottom is always negative. So if you take a positive number, positive huge number, and divide it by a negative number, you will get negative number. And so the answer is negative infinity, not positive infinity. Now the next example, we have the top and bottom both have the same exponent, both have the square, which means the powers are the same. So the top and the bottom are equally matched. So the top equals the bottom, which means the final answer will be the ratio of the leading coefficients, which are the numbers in the front. So for the top, the leading coefficient is 3. For the bottom, the leading coefficient is 4. And since both top and bottom grow at the same exact rate, eventually this limit will simply become 3/4. And then the last example is the top has the highest power is 1, the bottom has 2, so the bottom grows faster than the top, which means we have this last case, the top is less than the bottom, and so the answer will be 0. And that's our final result. The answer is 0. We can also check this work using the calculators by plugging in each one of these into our y function and seeing what happens as x gets larger and larger and larger. And we can do this right now. So let's look at the first example and see if we can do this, if we can come to the same conclusion. So here is our calculator, and let's type in into y equals, let's type in the whole question. So we have 3x to the 2 plus 1 divided by 4x, we need parentheses, 4x minus 1, and 4x minus 1. Okay, that looks right. Now let's look at the picture. So here is zoom 6, the standard window. So we are asking, as x gets larger and larger and larger, as x goes to infinity, what's happening to the y value? Well, it's getting bigger and bigger and bigger, and so it will go to infinity, just like our calculator says and just like our work by hand says. If we do this with a table, we can go to the table and we can actually plug in the values for the x and see what happens. And if you want to actually have the calculator plug in values, we can go to the table set, which is here in the window, second table set. And instead of going automatically, we can have it ask. So if we ask, that means we get to plug in our own x values, and then the computer will tell us what to get. So we are going, x is going to infinity, which means it gets larger and larger, and we are asking to see what happens to the y. So let's plug in positive 1. That answer is 1.3. Then 10. The answer is getting bigger. Then let's go 100. Answer is 75,000. Bigger and bigger and bigger. So the larger the x gets, the larger the y gets, which means we are going to positive infinity, just like the calculator said. Now let's look at the second example. This time the function is the same, 3x squared plus 1 divided by 4x minus 1, but this time we're going to negative infinity. So we are plugging in negative numbers and seeing what happens to the ratio. So here is the table. Now let's plug in negative numbers. Negative 1, we get negative number. Negative 10, the answer keeps negative but gets more negative and more negative, which means it's getting smaller and smaller. So here is again more negatives, and that shows numerically with a calculator that in fact our limit is going to negative infinity, just like what we said. Now let's look at the third example. So here we have 3x squared minus 1. Let's type in minus 1. 4x squared plus 1, and now plus 1, and now let's see what happens to the ratio. So we're going to the table, and as x goes to infinity, let's delete all of these values and we'll start over. So delete, 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 and we're going to plus infinity. So let's start off again. 1, that's a ratio of 0.4, 10, 0.74, 100. And we are asking, is this number getting bigger, smaller, or is it stabilizing at some particular value? So far it looks like we're getting closer and closer to 0.75, and in fact the higher the x goes, 0.75 is going to stay the same. So we are flattening out at 0.75, which is exactly 3/4. That's exactly what our answer said by hand. And so the final answer then, let's look at the last example with the calculator. That's 3x to the first, so let's not have any exponent here, minus 1, this time it's plus 1, 4x, no exponent, minus 1, and let's have a look at that table. It doesn't like the spaces, so let's do this all over again. 3x plus 1 divide by 4x to the 2 minus 1. And so let's look at this ratio and see if the ratio is going up, down, or is it becoming flat. So here is, once again, as x goes to infinity, let's start off with 1. you get 1.3. We plug in 10, it gets much smaller, 0.07, 100, 0.075, getting smaller and smaller. There is more and more zeros showing up, so the number gets smaller and smaller and smaller. This means e to the negative 4, that means exponent negative 4. So that's like 7.5 times 10 to the negative 4, which means move the decimal over 4 places to the left. So this is more zeros than the previous example. So there's more and more zeros, and eventually we're going to 0, which means our answer is correct. So we have confirmed our work by hand using the calculator. And that's how we can use the technology to verify our work by hand when we are on a test or on the homework. And that's it for this video. If you have any questions on anything, please let me know. Thanks for your time.